So let's continue from the question that we left. Here it says that BC is 12, AD is 8, and find the radius of the circle.
CE is 12.
Okay, also CE will be 12.
DE will be 8.
Okay. This is 8, this is 12.
AB will be 12, 20.
What?
No. teacher, no.
Okay. Yes, something else?
EO will be a straight line, a straight angle.
Straight angle.
Yeah.
OE. You mean this one?
Yes.
Draw, and it will be straight angle or right angle?
Right angle, yes.
Not possible, straight no.
Oops, I cannot draw. You mean this one, and this is R,
Yeah.
and this is R. And then what can we do more?
Yeah, we can do that one as well.
Yes, we can do, but what will help to us, that one?
Another line, teacher, from
From? Another line from?
C to O.
C to O, yes, but what will help to us when I will draw another line?
It won't help.
But look, if these are tangent lines and this is tangency point, also this part is perpendicular and this part is perpendicular. Yes?
Yeah.
So if I will clean this one here, but if I will draw a line from D, like, you know, a straight line, let me take our ruler. So a straight line from D to the CB, like here.
Teacher, now C, can we write a point or not?
What?
Can we write a point between C and B or not?
Yes, we can write, let's say, A, B, C, D, E, F. Here we have F.
And CF, can it be 6 or not?
Why 6?
Because it is perpendicular.
No, here you cannot say like that, but because these are like 90 degrees and I draw the parallel to the AB, also this one 90 and this one 90, it means that if this is 8, BF will be 8. And if BF is 8, CF will be
4.
4. And this one, DF, is 2R. Yes?
Yes, 2R, yeah.
This one is like 90 degrees. And we have another right triangle here. So what will be 20 square is equal to 4 square plus 2R square. So this is 400 is equal to 16 plus 4R square. Am I right?
Yes.
So 400 minus 16. will be
384.
384 is equal to 4r square.
R square will be
384 over 4, what will be?
384.
96.
196 it will be.
What will be?
96.
96.
96. Then r will be root of 96. So you can do some simplifications here if you want. 96 is divisible by 4, I think. Or not? I'm not sure.
It is by 2.
It's by 4, yes.
Yes. What is the result?
24.
24.
So it is
Also with
divisible by
16.
16. It means
Yeah, 16 times 6.
16 times 6. So it means that 4 root of 6 is the radius.
Yes.
Okay. This is 81. Yes. Okay. Did we understand? Yes, you will say okay now.
Yes, teacher.
Yes, okay. Is someone writing?
I will watch the video.
Okay.
Teacher.
Okay, so let me take the attendance. If you're not writing, I will open the other question for you to think about it. What can we do while I am taking the attendance? Yusuf,
Can you go back, take a screenshot?
okay.
It's okay.
Anita is here. Anita? Alexander?
Here.
Eva?
Teacher, I am here. Teacher, I'm here.
Elsa?
Here.
Here. Amra?
I'm here.
Yona?
Here.
Here. Stephanie?
Here.
Here. Fatih? Fatih? No. Kibariye?
Here.
Ringa? Tringa? No? Ardita?
I am here, teacher.
Okay. Arta?
I'm here.
Yovana?
I'm here.
Here. Vesa?
I'm here, teacher.
Okay. Stanislav? Stanislav? No. Salman?
I'm here, teacher.
Okay. Rumeysa?
Here.
Sara? No, I think. Ermal?
I'm here, teacher.
Ermal is here. Hamza? Hamza? No. Besa?
Here.
Here. Okay. Now, let's
Teacher, also I am here because I have some problem with internet and I can't hear you.
okay, Anita, I wrote you as present.
Teacher,
Okay,
also
thank you.
Tringa just texted me. She's here, but she has problems with her internet connection. She has
Uh-huh.
heard you, but she can't talk. She is here, though.
Okay, okay, thank you. In this question, it says that AP is 6 root of 3. And the angle, measure of the angle APB. APB is 60 degrees. Find the radius of the circle.
First, we teacher PO is a bisector of the APB. So
Angle.
APO will be 30 degrees.
So this angle will be 30 degrees, okay?
And also the other one will be 30.
30, 90, 60.
Where is the 90 and where is the 60?
Okay, we don't have.
Yeah. If we put
If I will
Right.
draw the radius here,
It will be a 90 degrees, so we have one. 90.
why I cannot draw it? Okay. So because we are drawing from the center to the tangency point, this one will be 90 degrees. Here we have 30. Here we'll have 60.
The radius will be 6.
The radius will be 6. Finished. The question
yes.
finished. Yeah. So when you know the properties, when you remember the properties, everything is very easy, yes? And clear.
Yes.
Yes, teacher.
So as you see, we didn't have anything to solve, to write here, to solve. Everything is clear there. It's okay. Here we are finishing with tangents. Now we have arcs and central angles. Arcs and central angles. Let me open this one, is the first page. As you can see here, we have two circles which have only one common point are called tangent circles. We had tangent line, we can have also tangent circles, the circles that are tangent to each other. So we have two types, externally tangent circles like this, outside, both of them it's outside, or internally tangent circles like this, if one circle is inside of the other circle, and they intersect each other exactly in one point. So here, as you can see, we have something written. Look, what you understand from these expressions here, C1 is the circle 1, and C2 is the circle 2. Okay, this one. C1 intersection and C2 is equal to A, the point A. Their only common point is A, it means, okay? And radius 1, the radius of the first circle plus the radius of the circle, second circle, radius 2 is equal to A, another distance, okay? So here we call them externally tangent circles, and L is the common tangent line. Here in the second one, if the circles are internally tangent circles, as you see again, C1 intersection C2 is equal to A, the point A, but here R1, the bigger radius minus the smaller radius will give you the A, the distance between two centers, O1 and O2. Now, what we have here in this question, let's see. Circles in the figure with centers A, B, and C are externally tangent to each other. AB is 16, BC is 12, AC is 14. Find the radii of the circles. So if I will say that the circle of this, the radius of this circle is R1, and this one is R2, and this one is R3. So what can I say? So this one is R1, this one is R2, and here I have R3. AB is equal to?
It's R1 plus R2.
R1 plus R2.
AB is R1 plus R2, which is 16.
16.
So BC,
R2 plus R3,
R2 plus R3, which is
12,
12. And AC,
is R3 plus R1, which is 14.
which is 14. Now here we have 3 equations, 3 unknowns. If I will use these 2 and add them, what I will get? R1 plus 2R2
2 plus 3 is
plus
equal
R3.
to 28.
28. Do I know R1 plus R3 from the
14.
It's 14 plus 2R2, which is
2R2,
R2,
R2 is 7.
R2 is up.
14, so R2 is 7. If R2 is 7, what will be R1? Because
It will
Minus
be
7, which is 9.
16 minus 7, which is 9. And R3, what will be?
14 minus 7, which is 7.
7. So we have
R3, okay.
7, 9, and 7. Okay. Did we understand?
Yes, teacher, this is spread.
Teacher, R2 plus R3, 7 plus 5 is 12.
So what is the problem here? With R3, we found anything? It's not working?
With R3, it's not working.
28, R1, R3, R1, R3, AC, 14.
14.
Okay, we took to the other side. It's 14 again. Divided by 2, 7. R2, 7. R3, 3. But here, there is a problem. R2, 7. R1, 9. Okay, it works. But here, R1, what we did? We did here,
R1 is 9.
R1 is 9. Why we subtracted 7? 14 minus 9 will be
5.
5. 14 minus 9 will be 5. Then it works, yes?
Yes, yes.
Okay. I don't know what we, or I wrote like directly, or you said, I don't know. It's okay?
It's okay.
Okay.
Yes, teacher.
Yes, teacher, it's okay.
Okay, now let's see here some other definitions. We have lots of definitions.
Teacher, can you go back? I forgot to take. It's okay, teacher.
Mhm. Arc. What does mean arc? Do you know arc? Have you ever heard arc?
Yes, teacher.
Arc.
Walk on Macedonian.
Also, you use arc in Macedonian?
No, walk, like fusion walk.
Uh-huh.
We say arc.
So an arc of a circle consists of 2 points on the circle and the unbroken part of the circle between these 2 points. So as you see here, we have 2 points from A to B. This is an arc. Also from A to C. This is an arc. From C to B, it's an arc. Okay? So this part of the circle is called arc. So as you see here, we have the smaller arc is called the minor arc. This one, the smaller one. And the larger arc is called the major arc. AB will be the major arc. ACB, let's say like this. ACB will be the major arc. AB will be the minor arc. Okay? The smaller one will be minor. The bigger one will be, the larger one will be the major arc. An angle whose vertex is at the center of a circle is called a central angle. So vertex is this one. If the vertex is the center O, this angle, for example, BOC is a central angle. AOC is a central angle. Okay, and here there are some important properties about this central angle and the arc. The degree measure of a minor arc is equal to the measure of its central angle. For example, if we are talking about this angle, AOB, for example, this angle, AOB, and is here, AOB is 180 degrees, it's a straight angle, yes? So also this arc, AB from A to B is 180 degrees. Also, the measure of the arcs is shown with degrees, guys, as the angles. So as you can see here, this line up shows that this is an arc, okay? So measure of AB, arc AB is equal to the measure of angle AOB. And this one, the measure, this arc ACB, this arc semicircle, half of the circle, semicircle. Now, as you can see here, some figures are given, and arcs, the measure of arcs are given. We are looking for the measure of the angle. If the arc AB is 50 degrees, what will be the angle AOB?
It will be 360 minus 50.
Directly, you can say that it is 50 degrees. What we said? What will I said here?
Wait, for which teacher? I didn't understand.
If you have central angle, I was talking here about it. If you have central angle, the arc that is opposite to the central angle, for example, this is the central angle. These two rays are forming.
Yes, it will be 50.
So this arc is same as this angle. Okay.
Okay.
We can draw even the smaller one. It will be small or big.
Yeah. So if this one is 50 degrees, the angle will be 50.
50 degrees.
If this one is 120, the angle
100.
The same 120.
If this one is 180, the angle will be 180. But this works when your angles are central angles. If the vertex of the angle is in the center point. If you have this kind of circle, center is here, and you have something like this. This one and this one is not same.
Why, teacher?
Wait, because the vertex is not in the center. This is the vertex of the angle. It's not in the center. If it is in the center, like this, then this angle and this arc is the same, okay? But this one, no. What is the problem, Salman? What part is the problem?
No, teacher, I understood all, but why it isn't? Because it's the same, even as the small one.
It's not the same. If the vertex is not on the center, when you will draw an angle here, this angle and this angle, they are not the same. It won't be the same.
Okay, now I get it.
Yeah. Now, guys, let's see what we have more about this. Inscribed angles. These were central angles that we were talking about. Inscribed angles. An angle whose vertex is on a circle, in the circle line. The vertex is in the circle line, and whose sides contain chords. Look, this is BC is a chord, yes? BAB is a chord. And these are the sides of the angle ABC. It's called inscribed angle. the measure of an inscribed angle is half the measure of the central angle which intercepts the same arc. So as you see here, look, this is an inscribed angle and this is COA is a central angle, but both of them has the same arc in front of them. Yes? So this angle is half of the arc. If arc is 2 alpha, the angle will be alpha. Okay?
Yes.
Yes?
Yes.
Okay. The measure of an inscribed angle is equal to the half the measure of its intercepted arc. So if here, for example, the angle is given 50 degrees, what will be the arc?
50 degrees, it will be 100 and 100.
100.
2 times 50, 100.
Because x will be equal to 2 times 50, which is 100. Ah, be çocuklar. I'm continuing. I will not ask anymore if it is okay. I am continuing. Did you take your screenshots?
Yes.
Yes.
Okay. Now A we solved. It's,
No, teacher. Wait.
you said yes.
No. It's okay now, teacher.
It's okay. Now here, in this example, we solved A in the previous one. If it is, this one is 50, x is 100. What about here? If the arc is 120, x what will be?
6.
120 divided by 2, which is 60. Here, the central angle is given as 90 degrees. What will be this one?
It will be 45 degrees.
It will be 45. Why? Because it is the half of the central angle and it will be 45 degrees. Okay.
But teacher, even if how to say, the lines are not the same with the inscribed angle.
Which lines?
For example, teacher, in the C
Yes.
version, the lines of BC and BA are not the same as AOC and OA.
Yes. Lines doesn't matter.
Doesn't matter?
No, we are talking about
Okay.
the lines, the sides are not. You mean because it's not like here there is not same distance like.
Yeah, it's not the same in the both
Yeah.
sides.
No, it doesn't matter. They are looking to the same arc here. Look, they are endpoints. They have
Okay.
the same arc. Because they have the same arc, these parts doesn't matter. It's directly half of it.
They should have the same arcs.
Arc, yes. But
Okay.
it was like this, Salman. Let me take. Look, this one is here, and this one goes somewhere else, not into A. So you cannot talk about this 90/2 because they don't have the same arc with this.
They should pass through the same
Yes.
last points. Okay.
Yes. They need to take in front of them the same arc, same distance.
Okay.
Here we have some more properties, but I will give these properties next lesson on Wednesday because it's too much properties for today. Everything will be mixed. As I can see, and you are not here at all. So see you on Wednesday, guys.
Teacher, we will have all this on the exam?
Yes, I wasn't thinking to ask, but because of today's activity in the lesson, everyone was very active and I will ask them. I'm not explaining them to myself. Okay?
And teacher, we will finish on Wednesday with the circles or no?
Yeah, mostly we will do. I mean, we have done like 3 lessons, 3 of them today. So we'll do Wednesday like 2 more, and it will be enough. At least you
You
have-
sure next week no lessons, right?
I cannot say that one, the teacher, you know.